Okay, we're on page 57 here. And we're going to title this Water Quality. And notice that I flipped my paper sideways for taking notes. Okay, we'll add our river, creek, right down the middle here. And when we tested Camille Creek water, one of the things that we tested was dissolved oxygen. So put number 1, dissolved oxygen. And dissolved oxygen in a creek or a river is a good thing. And that's because the things that live in the water need to breathe just like we breathe, but they breathe dissolved oxygen that's mixed in with the water. So we can say for like animals and insects that live in the water to breathe. And dissolved oxygen can come into creeks from plants that are supposed to be there. Sometimes you see little ripples in the water, and those are rapids that help put dissolved oxygen into the water. Even a rainstorm, when it splashes in the water, can bring dissolved oxygen into the water. Another thing that we tested when we tested Camille Creek water was the temperature. So number 2, but we'll put down low temperature is what we want in creeks and rivers around the Pacific Northwest. So colder, generally around here, is better. And this is good. And mostly because lower temperature water holds more dissolved oxygen. We'll say DO for dissolved oxygen. And things that help lower the temperature of the water, if there's trees that cover the rivers, that shades them so they don't get hot in the sun. And then of course, the more water that infiltrates into the ground when it lands on plants or grass or trees, and then makes its way to the creek as groundwater, that helps keep the temperature low in the creeks and rivers. So the more natural surfaces or porous surfaces where the water can soak into the ground, the better that is for the creek or river. Now, kind of the opposite of that is another thing we tested, which was number 3, and that was turbidity. And turbidity is something that's bad. It's dirty water. And one of the things that makes more turbidity is runoff. So we'll say from runoff. And of course, the plants that live in the water don't like turbidity because that makes it hard for them to get the sunlight. And the animals that live there can't breathe as well. Turbidity actually raises the temperature too because it makes the creeks and rivers darker and absorb more sunlight. So turbidity is not good for water quality. And turbidity can come from just like a really heavy rainstorm, but in a city, usually it comes because water lands on houses or it lands on streets or it lands on maybe parking lots. And when it lands on those kinds of surfaces, the water can't infiltrate. Instead, it runs off straight to the creek. So we'll say runoff. And that makes more water go to the creek faster, can increase flooding, and it brings the pollution that might be found on streets and roads and buildings with it into the river. Whereas groundwater, the soil tends to filter out the pollution before the water gets to the river or the creek. The fourth thing that we tested when we tested Camille Creek water was nitrates. And nitrates are bad for water quality. And they tend to come from chemicals that we put on our lawns and our farms that helps the plants grow. That's supposed to be a fertilizer machine. I know that doesn't look like it. And if too much fertilizer is used, then that fertilizer can run off and go into the creeks and rivers. And when it does, it increases the algae. And the algae has a bloom and it grows all at once, and then it tends to die all at once. And when it dies all at once, then it decreases the dissolved oxygen. And so the things that are living in the creek can't breathe, and that's obviously bad for them. The algae tends to be that green scum that you see on top of some waterways. And the last thing that we tested, number 5, was pH. And pH 7 is good. If it's higher or lower than that, it's not good. And pH basically comes from other chemicals that can get into the water from factories or houses, and those chemicals can change the pH of the water, which is not good for the creatures that live there. So overall, for water quality, we want more dissolved oxygen and lower temperature. That tends to happen when the water infiltrates and goes through the ground before it gets to the creek. And the things we want to avoid in the water are nitrates and turbidity and pH, and they tend to get on the creeks when there's a lot of runoff that picks up pollution and dirt and goes directly into the creek.